Algebra 3, lesson 55, 56. Normally, what we would do is we would spend a lot of time looking at what the book has to say about certain things. I'm going to just show you how to answer these questions, if that's all right with you. These first four, the first one for sure, we're talking about distinguishable permutations. So, imagine if we had like the word Mississippi and we wanted to know how many different ways there are to spell Mississippi given the letters, or not necessarily spell Mississippi, but how many different combinations are there for those letters. So if we did distinguishable, or if we did just permutations, we would take the number of letters and find the factorial of that. But distinguishable permutations means that if there's already an S in that position, then I'm not going to put an S back in that position, right? It has to be distinguishable, it has to be unique. So it means unique permutations, non-repeated. So we're going to see that, especially in question number 2. But question number 1 deals with sitting around a circular table, right? We'll start talking about this. And I don't know if I do a great job of explaining this, but we're imagining our circular table, King Arthur and his 4 knights. All right, so there's 5 seats. All right, 1, 2, 3, 4, 5. So essentially, because it's not in a line like this, first, second, third, fourth, fifth, there is no first, second, third, fourth, and fifth. But so the first seat, only one person can sit in. Right, but when we get to the next one, it goes 4, 3, 2, 1. Right, so it's a little interesting. Instead of it being like 5 factorial like we would expect, and like what it would be if you were talking about everybody sitting on the same side of the table. When we start talking about a circular, it doesn't work the same way because we go around. So it's really, you're going to look at how many there are, and it's going to be one less factorial than that, because the first one is always 1. If it had been King Arthur and his 7 knights, it would be 6 factorial. Okay, so our answer on this comes out to 24, because 4 times 3 is 12 times 2 is 24, and we have these 2 ones that aren't going to add anything to that. So question number 1's answer is 24. Do we follow at least somewhat of the logic? All right. All right, so then we get into like question number 2. It says how many distinguishable permutations can be found from the letters in the word scapula. So the first thing that we're looking for is, are there any repeats? Well, there is, right? There's 2 A's. So as you look at scapula, we see 2 A's. And so what we do is we take the number of letters that there are, right? How many letters are there in scapula? 7. So we take that 7 factorial, but then we divide it by how many of them repeat, or how many times does something repeat. All right, well, there's only one letter that repeats, and that's A, but it repeats 2 times. So we take 7 factorial divided by 2 factorial. Okay, so you guys are going to punch that in your calculator and tell me what you get. $2,520. Now, like I said, we talked about the word Mississippi, right? How many letters does Mississippi have? 11. All right? But, so let's talk about the things that repeat. I repeats, right? M-I, S-S-I, P-P-I. So it repeats 4 times, right? So we would put 11 factorial over 4 factorial, but it's not the only thing that repeats, right? M-I-S-S. So you have S-S, M-I-S-S, I-S-S, I-P-P-I. So it's got 4 S's, right? And then we have P's, right? 2 P's. So we would have 11 factorial over 4 factorial times 4 factorial times 2 factorial. Right, so it's a much smaller number than if we took 11 factorial. 11 factorial is going to be huge, but this is going to greatly reduce the number of permutations I can get. Okay, and I'm not saying that I have that. you need to put the bottom in parentheses, because otherwise all it's going to do is it's going to do 11 factorial divided by 4 factorial, and then it's going to take that answer and multiply it by 4 factorial, 2 factorial. I am interested to know what the number is. It may still be a fairly large number. 34,650. Now, real quick, tell me what 11 factorial is, if we did it without distinguishing.
39,116,800.
All right, so there's a big difference between almost 40 million and 34,000, right? Distinguishing permutations is a way to kind of cut down on some things. All right, so let's look at number 3. There are 2 identical black flags, 5 identical yellow flags, 3 identical red flags. How many different patterns are possible if the flags are displayed vertically on a pole? Well, the display vertically on a pole really doesn't matter how they're displayed. But the first number that go on top is the total over the combinations, right? So we've got 2, 5, and 3. Was that 10? 10. So it would be 10 factorial, and then we put it over the factorials of our groups. So 2, 5, and 3. Don't forget your parentheses. Wait, did I miss? Oh, hopefully I didn't miscount. Oh, hold on, I'm looking at 3. Yep. 2,520. Kind of funny that was our answer for scapula, right? 2,520 come out to the same thing. Okay, so that's number 3. Let's look at number 4. Number 4 is still distinguishable permutations. 5 identical yellow books, 4 identical blue books, 2 identical green books. How many different patterns are there if the books are arranged on a shelf? All right, count up the number there are. How many are there? 11. Okay. 5, 4, 2. $6,930. Very good. All right. So really, distinguishable permutations aren't that hard, right? Okay. Let's see. Now we're getting into question number 5. Okay, we'll get into some different stuff here. We're going to learn how to find the area of a triangle that doesn't have a given height, right? We know how to find the area of a triangle. It's base times height divided by 2, but what do we do if we don't know the height and it's not a right triangle? Well, we can make it a right triangle by doing this right here, okay? Because the height is now going to be the one side of that right triangle, correct? All right, so we can find height. Now this is 54 degrees, and I think that's 138 feet. So what we have to do is find the missing length, height, of that right triangle based upon trigonometry. Now, we know some things. We know we're going to divide by 2, and we know that our base of this triangle is 144, correct? So don't forget what we're trying to do, okay? We're going to find the height, but that's not the final answer. So what we have is we know that h represents opposite of 54, 138 represents hypotenuse to that triangle, correct? Okay, so we're going to do sine 54 equals h over 138, right? So we're going to do 138 sine 54, correct? All right, and normally I'd go through the whole explanation on that, but we're algebra 3 and we should know that. What is 138 sine 54? Take it to the nearest tenth. 111. 111.6. So we're going to take 144 times 111.6, divide it by 2, and again, we're going to take that to the nearest tenth. 0.2, and we are feet squared, right? Because we're area. Okay, not too bad. All right, let's clear that up. And below that, we have a trapezoid. And if you remember your formula for a trapezoid, it's base 1 plus base 2 times height divided by 2. So that's the formula we're going to use. The only problem is, what are we missing? Height. We end up doing the exact same thing. We're going to make a right triangle here. Okay, we're going to find the height. We already know our base 1. Base 1 is 7. Base 2 is 11. We know we're going to divide by 2. We just have to find that height, right? So we're still using sine because h is still opposite my angle. 72 is still my hypotenuse. So we're doing sine 41 equals h over 72. So we're doing 72 sine 41. Okay, we're going to find that. Okay, let's take that to the nearest hundredth.
72. 47 point. Nearest 100?
Yeah. I think hopefully.
0.2.
Did I do something wrong here? Oh, it's 7. It's not 72. It's just 7. I'm sorry. Because I saw the feet there is not very clear. So 7. So it's just 7 sine 41. My bad.
4.5.
4.59. All right. So take 7 plus 11. So we got 18. 18 times 4.59 divided by 2. Right, and because it's an estimate, 41.33 is, we're pretty close. What would you say, 3-1? So we were 200ths off. All right, I'm not too worried about that. Okay, we pretty well have we got a pretty good understanding of what we were doing with those. Okay, being able to use trig to find missing heights. Okay, 7. This is area of a sector formula. We should already be familiar with this. This is old-time geometry and Algebra 2 stuff. Area of a sector formula. We take the area of a circle, which is pi r squared. We multiply it by the measure over 360. Okay, we found arc length by taking circumference times that fraction. Now we're just taking the area of a circle times that fraction. So if we want to find the area of a sector with a central angle of 2 pi over 5, what I would first do is convert 2 pi over 5 into degrees. Okay, round your answer to 1 decimal. So, okay. So 2 times 180 is 360. 360 divided by 5, 72. All right, so that's my central angle. So we're going to take 6.9. So we got pi times 6.9 squared. What do you say, 72?
Yeah.
72 over 360. And I would use pi if I was working it out. I would just, here, I'll show you what I mean. I would just do the whole thing at once. So I'm doing, second pi, 6.9 squared, 72 divided by 360. Close all that up. And yeah, I get 29.9 kilometers squared. Okay. Again, I don't think there's anything all that difficult in this lesson until we get to number 8. Okay, number 8 changes things up a bit. Okay, let me clear this out. All right, so I want to be careful on 8. 8 and, specifically 8. All right, we want to find the area of a segment bounded. Okay, so area of a segment bounded by an arc measure of 150 degrees and the chord joining the endpoints of the arc in a circle of a radius of 8 feet. All right, so this is pretty complex. All right, so the first thing we're going to look at that I'm going to do is I'm going to make an angle of 150 degrees. Okay, that's approximately 150 degrees right here. I know it's greater than 90, it's less than 180, so it's going to be something along that line. And what they're saying is we want to find the area of the segment bounded by the endpoints. Okay, we want to find the area of this shaded region here. Okay? All right. So what we're going to do is we're going to find the area of a sector, and then we're going to subtract the area of that triangle. Okay? So the area of a sector is pretty easy, right? We know that our radius is 8 feet. Okay? So we're going to do, pi 8 squared 150 over 360. That's the whole area. Okay? But then we have to find the area of the triangle, and that's a little tougher. Okay? Because we don't have a height, right? Our height is this right here. Okay? So we're going to end up making this 30. Okay? Which, let's see, as we talk about this is still 8 right here. Okay, you follow me? So what we can actually do with this, and this particular one, is we can use special right triangle ratios, because I know that this is 60. So the height has to be 4, right? So that works out really nice for us. All right, so we have, for the area of, now we have to find the area, though. So we're doing 8 times 4 divided by 2, correct? Okay. So what I'm going to do is I'm actually going to put this all in together. And probably shouldn't do this all that often, but I'm going to do second pi 8 squared times 150 divided by 360. Okay, and I'm going to close up all of that minus, well, we could probably do a lot of this in our head. 8 times 4 is what, 32? 32, and 32 divided by 2 is what, 16? Okay, so we're just going to subtract 16 out of that. All right, do they tell us how closely they want it? I'm not seeing anywhere where they do. And I get 67.77, which is the correct answer, 67.77, and it is feet squared. All right, so the basic principle here is take the area of the sector and subtract the area of the triangle, right? What you're going to be left with is that bounded region that they're referring to, okay? Okay.
Find the area of the triangle. Wait, I'm confused. Find the area of the triangle that's next to this.
This triangle is the area that we found, all right? Because we used this base of 8 and our height of 4, okay, to find the area of that triangle there. But we had to make this triangle in order to find the height, okay? Because the height has to be a perpendicular line to the base that goes to the opposite vertex, so sometimes that's outside of the triangle, okay? All right, let's see, let's look at 9. Find the area of a sector. This is goes back to like number 7. Find the area of a sector with a central angle of 180 degrees, radius of 15.7. You can do this. It shouldn't be a problem. You should get A for an answer. You should get 387.2. All you're doing there is taking pi times 15.7 squared times 180 over 360. Okay, and that should give you 387 over 2. All right, our last part here, number 10. It says graph the solution to the system of inequalities. You'll notice that this first one up here, that is the equation of a circle where we are 4 to the right and 0 up, right? 1, 2, 3, 4, right? And I'm there, and I've got a radius, it says is less than or equal to 5, right? So I'm inside, my shaded region is inside the circle is what we're saying. So I'm going to count, 1, 2, 3, 4, 5. Okay, I got a spot there. Okay, 1, 2, 3, 4. Okay, 5. So I've got a spot here. We're going to count up 1, 2, 3, 4, 5. Okay, we're going to get a spot roughly right around in there. Count down. 1, 2, 3, 4, 5. Okay, it's just got to be pretty basic. Okay, we're going to get something like that, where inside the circle is what gets shaded. Okay, so instead of shading, if it had said greater than or equal to 25, my shaded region would be outside of the circle. Okay, that's all that inequality is telling me. The rest of this is a parabola. Okay, So it's telling me where the vertex of that parabola is. Notice that it has no plus or minus outside the parentheses, so its y-coordinate is 0. All right, and its vertex then is at 4, 0. Do we see that? Right, notice that it's positive, right, so it's going to open upwards. So it should open up something like that. The next question is, well, it has, essentially, the question is it shaded inside but not inside the parabola, or is it shaded inside the parabola? And because it says y is greater than, that means it's shaded inside here, okay? Because the parabola going up, if it's greater than that, it's going to be inside of it. So that's how we end up doing that, okay?
Yeah.
All right. All right, well, I'm going to hit stop right there, and you guys have the next 14 minutes or so to work on your homework. So